About Euler's method and its modified Euler's formula. So first we need to apply Euler's method in order to find for modified Euler's method. So now let me define the formula first, formula of Euler's method as well as modified Euler's method. The first, the formula we will be defining for Euler's method, then followed by modified Euler's method, because to apply modified Euler's method we need to use Euler's method formula. So let us go to the formula of Euler's method for a first approximation. So the first approximation, it is y1 will be equal to y0 plus h times f of x0 comma y0. This is the Euler's formula for first approximation. And next we'll see to it that the formula for modified Euler's method. Modified Euler's method. So here in this modified Euler's method, actually we go with minimum 2 or 3 approximations. And while applying modified Euler's method, we required whatever the formula or whatever the value that we got in the Euler's method. So now let me define the first approximation in the modified Euler's method. That is y1. See, this is in the bracket which I am going to write. This is our first approximation. So y1 at its first approximation, it is given by y0 plus h divided by 2 multiplied by f of x0 comma y0 plus f of x1 comma y1, and this y1 we will be using the one which we got from the Euler's method. So this is the formula of Euler's and modified Euler's method. So now let us look into the problem. Let us take one problem on this. So we'll go with one problem. Let me take down the first problem on this. See, they said that solve using modified Euler's method. Solve using modified Euler's method, and the differential equation that they have given it is y dash of x is equals to 3x plus y by 2. This is also a very important question in your exam point of view, as well as this question is given in your model paper also. So they have given the differential equation y dash of x is equals to 3x plus y by 2, and the initial condition that they have given it is y at 0 is equals to 1, and then they are asking us to find the value of y at x is equals to 0.2. It is at x is equals to 0.2 with at x is equals to 0.2 with the common interval h as 0.2. So this modified Euler's method as well as Euler's method, we are supposed to do, suppose if the question takes with more number of common interval, then you are supposed to go by 2 stage, or else only 1 stage is enough. So how do we get to know that the problem has to be done in only 1 stage or the problem has to be done in 2 stage? Means, see, we have to look at the value of the given initial condition, and we have to look at what value we have to find for y to provided x value. See, here the initial condition for x, they have given it as 0, and we need to find the value of y at x is equals to 0.2, and they said that the common interval it is 0.2. Thus the problem will carries out with only one stage. So let me write down this once again. They have given the initial condition x0 as 0 and corresponding y0 as 1, and they're asking us to find the Euler's method. I mean, they're asking us to find the value of y at x is equals to 0.2. This is a question mark which we need to find, and they have given the common interval h as 0.2. So this is where we will be getting to know that the problem has to be done whether in one stage or whether the problem has to be performed in two stage. So as they have given with only one stage, so I mean this problem will goes with only one stage. So now let us find that. See, first we will take from Euler's formula. First we need to find what is the value of y1 in order to apply modified Euler's method. So let me define the formula for Euler's method, that is y1 is equals to y0 plus h multiplied by f of x0 comma y0, f of x0 comma y0. So we have the value of we have the value of y0, that is 1. We have the value of h, that is 0.2, and f of x0 value it is 0 and y0 value it is 1. So this you are supposed to find. See, f of x0 comma 1 means you have to substitute in y dash of x, because we have defined the general equation as y dash of x is equals to f of x comma y. So this together it will gives the value as, I'll just write down this once again, 1 plus 0.2 multiplied by, see, f of x comma y, they have given it as 3x, and here the value of x it is 0, plus y divided by 2, and the value of y it is 1. So 1 divided by 2, I mean the value of y0 it is 1, and this together gives the solution as, it is 1.1. So this 1.1 is the value we got for y1 at x is equals to 0.2 by using modified Euler's method. So now let us move on applying for modified Euler's method. So modified Euler's method, we will first write down the formula first. So this is the modified Euler's method that I am going to apply now. So we are going to apply modified Euler's method, and the formula we define it is y1 at its first approximation, it is equals to y0 plus h divided by 2. This is multiplied by f of x0 comma y0 plus f of x1 comma y1 at 0 approximation. 0 approximation means just now we have taken the value for y1 by using Euler's method, right? So that itself we will be using as a 0 approximation. See, I am specifying here, this is my y1 at 0th approximation. Okay, so now let us substitute the values. Y0 we know that it is 1 because it's a given initial condition. H value it is 0.2 divided by 2, it is in the formula, multiplied by f of x0 comma y0. X0 is 0, y0 is 1, plus the next followed f of, see, x1 value it is 0.2, it is because initial value it is 0, we have a common difference of 0.2, so hence my x1 will be 0.2, comma y1 at 0 approximation we got it as 1.1, that is which we got by using Euler's formula. So now on substituting this in our equation, we get the solution, I mean we get the value as, I'll just show how we have substituted for this step. It is 1 plus 0.2 divided by 2, this is multiplied by, see, f of 0 comma 1, it is nothing but 3 times 0 plus 1 divided by 2, and this is next followed by plus f of 0.2 comma 1.1, that is 3 times x value, now it is 0.2, plus now the value of y it is 1.1 divided by 2. So this together if we calculate, we get this solution as 1.165 it is. So this is the value of y1 at first approximation. So similarly, we'll be finding what is the value of y1 at its second approximation. See now, we're going to find the value of y1 at second approximation. See students, for each and every step you have to write down the formula. So now for this, the formula will be y0 plus h divided by 2 times f of x0 comma y0 plus, now it becomes f of x1 comma, see before I have used y1 at 0 approximation, now I will be using y1 at first approximation value. Okay, so hence this will gives the value as, directly I will be substituting in the function. So y0 value is 1, h value it is 0.2 divided by 2. This is multiplied by, actually x0 is 1, y0 is 1. So that when we substitute in the function, we get it as 3 at 0, 3 times 0 plus 1 divided by 2. Next, followed by plus. Now f of x1 it is 0.2. y1 at first approximation. See y1 at first approximation. This is we have here. So thus here we will be getting this value as So here we will be getting the value as 3 multiplied by x1 value it is 0.2 plus our y1 at first approximation we got it as 1.165. I have enlightened that, and that is divided by 2. Okay. So this calculated solution we get it as 1.1682. So this value, see you have to compare this step y1 at second approximation with the previously obtained approximation. You have to compare at least for 3 decimals. Okay. So now let me move on to the next approximation, that is same y1 we are finding at its third approximation. So the formula becomes y0 plus h divided by 2 multiplied by f of x0 comma y0 plus f of x1 comma, now it is y1 at second approximation here, the value. So this will be this will gives us y0 value it is 1 plus h value it is 0.2 divided by 2, and this is multiplied by same thing, that is x0 is 0, right? So 3 times 0 plus y0 it is 1, so 1 divided by 2 times plus, now it is x1 it is 0.2 and y1 at second approximation we have got here. See, I'll be just highlighting it. I'll be just highlighting those value. y2 at my second approximation is this one. So that I'll be going to substitute in this place. f of x1 comma y1. Okay. So let me substitute that. It is 3 times x1 it is 0.2 plus the value of y1 at second approximation we have it as 1.1682. So this calculated value we will be getting it as, its calculated value we get it as 1.1684. So almost, see, by the time of third approximation we'll be getting at least minimum 3 decimals will match with my previous approximation. See, these 3 decimals, see this is the current obtained approximation now, and this is matching with my previous approximation. You can see the previous approximation that we have got it is 1.1682 and current approximation we got the value as 1.1684. Thus the required root. Thus the root of this equation is, we got the value of y as 1.168 at x is equals to 0.1. Sorry, x is equal to 0.2. So this is how we solve the problem for a first order first degree differential equation using Euler's method. And this problem, it is at first one stage. Suppose if they ask us to find, so I'll just note here, second stage, it will take second stage of the problem. Till now, whatever that I have explained, same formula we will be applying, but only the thing it is, we will be taking for x2 as 0.4, and at x2 0.4 we need to find what is the value of y. We need to find what is the value of y2. So for this, we will be applying the same set of formula which I have defined previously. Okay. So this is how we solve the problem using Euler's method and modified Euler's method.